Hey there, Year 9s. In this video here that I'm making, we're going to be doing exercise 9B, Venn diagrams and two-way table notes. In this example, I just want you to take these notes down. You've got, on the left-hand side, it's called a Venn diagram. And then on the right-hand side, it's called a two-way tables. That's also known as the Carnot maps. They're both just tools for you to be able to solve probability questions or problems, and both of which have their own unique pros and cons. I use a Carnot maps mainly for calculation, so anything to do with calculating number of intersections between two sets, whereas a Venn diagram, I like it as a visual aspect. Okay, so for your notes, fill this in. The region that both A and B have something in common, we call that region A intersection B, meaning what is in group A and in group B that they both have in common. Whereas in this region here only, okay, that region there, you can see that only has part of A. It's still within A, but it's not part of B. So we call this region here, we say this is the part of A that intersects, which is in common with not part of B. True, because part of B, this is all of part of B. So anything that's outside of B, so if this is B, right, then outside of B must be everything else, right? So that yellow region, where does yellow and the blue region both coincide? Well, they both coincide within this small little region here. Does that make sense? Okay, so that's why we say that this region that you're seeing that I've just highlighted before, this region where it's only A, okay, only A, nothing to do with B, that is called A intersection B dash. Then similarly, you'll find that this is now not part of A, but intersects with B. And then finally, you've got your fourth region, which is it might not be part of A at all, and it's also not part of B. Okay, so those are your four key regions there, which actually coincides with the four regions that you have in a two-way table. So you've got your 1, 2, 3, and 4 boxes there, and that signifies the four regions that we've just talked about. So in box number 1, you can see here, this is where A and B are in common. So that means that this region here that I'm coloring in green, this is region number 1. Okay, so that's A intersection B. But what I want you to see as well is that when I take region number 1, okay, and I add with region number 3, okay, can you see if I add vertically down, add these two regions together, that should give me the total of A. So this is total for A. So which one would correspond as A but not part of B? Well, this is A but not part of B. So this region that I'm coloring now in yellow, if you add the yellow region and the green region together, can you see it actually gives you all of A? This is all of A, true? So yellow and green regions colored together gives you all of A. And so that means this must then be the region number 3. Again, hopefully you pick up now then this is not A but part of B for box number 2. And so that means not A but part of B. That must mean this is then region number 2, which gives you this blue region here. So this is blue. That's region, that's where it's not A but part of B. And then finally you've got your outside. So again, I'm just going to color code it so you can see. There we go. So I've colored the regions. So green is with green, yellow is with yellow, and then blue is with blue. And then obviously white is with white. So not part of A and not part of B falls into this category here. And so if you follow the two-way table, you can see that if I add regions 1 and 2, so blue and green together, you get a total for B. So this is the total for B. And then obviously this will be the total for not B, total for not A. And then obviously if you add B and not B, well then you get everything. So we call this the universal set or total. Okay, so you get everything in this region here. You can think of it as like the epsilon symbol for the entire sample space. Okay, or if we're doing probability, we know it's the total probability of 1 because it's 100%. You get everything. Yeah? All right, so what you see there is the notes that I want you to have for your exercise 9B notes there. Let's do an example now. Let's put it together. Let's have a look at this example here. You got fill in the blanks for the Venn diagram. So I've got the regions for you here. We've got C for liking coffee and then T for liking tea. So the people that like both coffee and tea, we've got 20 of them. Now, if this is coffee and this is tea, well then for them both to like it, that means 20 must go in the center where both of them are coinciding. Whereas the number of people who don't like coffee but yet still like tea, there are 10 of them. So they still like tea, but they don't like coffee. They don't want anything to do with coffee at all. So that means 10 must go into this region here. And then now that we got that, we should have a total for people that like tea should be 30. So this is all of tea. These are the people that like tea, and you got 20 plus 10. That's true. That is 30. That is correct. Now, if you know there are a total of 50 people in this survey or experiment, well, then how many people don't like tea? If you got 30 that like tea, well, then there must be 20 that don't like tea. Get me? So I just did 50, take away 30, gives me the 20. And then similarly over here, well, then this must be, 15 people who don't like coffee. Now, you can figure this out here. You can say, well, 5 plus something has to give you 20. And so 5 plus, and hopefully you figured out that should be 15. Or you could have done it vertically as well. 20 plus 15 gives you 35. So we fill in the regions now. Who likes coffee but not tea? Well, we've got 15 who love coffee but not tea. Okay, and then lastly, who doesn't like coffee and tea? Well, you got 5 of them on the outside. So if you actually add all the numbers together, 15 plus 20, that gives you 35. Plus 10 is 45, plus another 5 gives you 50. So it actually matches up that it should be 50 people in total. Okay, so that's just using the Carnot maps as a way to calculate all the regions, and then the Venn diagram just gives you a visual aspect to it. Okay. So let's answer the questions now on the back. Let's pick this example here. Let's see if we can answer the questions here. So example 2, 30 people at a gym. So there are 30 people at a gym are asked about their gym usage. Of these, 18 of those people attend the classes, okay, and 19 people use the gym equipment. And then 8 people attend classes and use the gym equipment. So you have either attend or gym. So you can attend and not attend. You can use the gym equipment and not use the gym equipment. Okay, so what we know is that 8 people attend the classes and use the equipment. So I know this must be 8. They both attend and they use the equipment. Now here you got to be careful. 18 people attend classes. Okay, that doesn't mean that that essentially just means that if I looked at the total of people that attended, well, there are 18 people who attended. Okay, regardless of whether they use the gym equipment or not, it's just 18 people who attended. Similarly, 19 people use the gym equipment. So this is used gym equipment. So 19 people in total use the gym equipment regardless of whether they attend or don't attend the gym. Which is funny because, well, for you to use the gym equipment, you probably have to attend the classes. Oh, actually, no, attending classes is different to using the gym. So you might go to the gym, but you might not attend the classes. You might go to the gym and then just use the gym equipment. Okay, so here, if we then got our two-way table, it makes it easy to fill in the blanks now. They all need to add up to 30, so this must be 11. 19 plus 11 gives you 30. This must then be 12. 8 plus what gives you 19? Well, that must be 11. And if that's 11, well, then this must be 1. And then this must be 10. Okay, so now that you've got those regions there, you should be then able to fill out the Venn diagram. So that means 8 goes in the center. That's where both of them they use the gym equipment. They attend classes as well. You've got 11 people who don't attend classes but do use the gym equipment. So gym exclusively. And then 10 people over here who attend classes but they don't use gym equipment at all. So 10 must be there. And then finally, those who don't attend classes and neither goes to the gym, there's only one person who doesn't. Now, if you add them all together, those 4 regions, they should add up to 30. So let's see, 11 plus 8 is 18. 18 plus 10, 11 plus 8 is 19. 19 plus 10 is 29. And 29 plus 1 gives you 30. Okay, so Venn diagram's all nice and chilled and done correctly. So now we can answer the questions, and you can either use the diagram or you can use the Carnot maps. How many people do not attend classes? Well, this is a 10, so not a 10. There's a total of 12 people who didn't attend classes. How many people neither attend classes nor use the equipment? Well, we know there was one before. And then find the probability that a randomly selected person uses the gym equipment. So probability, PR, that uses gym equipment is probability of G. Probability of G. Well, probability of picking someone at random that uses gym equipment, well, you've got a total of 30 people to choose from. And out of those 30 people, how many use the gym equipment? Well, we know that there's a total of 19 that use the gym equipment. So you got a 19 out of 30 chance of picking someone that would use the gym equipment. And then find a probability that a randomly selected person only attends classes. Keyword is only. So if you're only using or attending classes, so that means A exclusively, well, attending class exclusively without using any gym equipment is only 10 people. Only 10 people attend and not use gym equipment. So they're only attending classes. Yeah, so that means probability of G, so not using G, not using gym equipment, but yet attend classes is equal to, there's only 10 out of 30, which is a third of them. Okay, so a third of them will attend classes but not use the gym equipment. And finally, find the probability that a randomly selected person attends classes or, now that's a key word, or uses the gym equipment. Okay, so what they're really asking you here is to find what's the chances of picking someone who attends the classes or, so they have an option now, so or is union, uses the gym equipment. So if you think about it, well, the people that attend classes, there are 18 people. So you can pick 18 of they've got 18 people to choose from. Or they could also be the people that go to the gym. So use the gym material. So if I use the gym, actually I should do a different color so it's easier to see. So this was attend class. So you have 18 people out of 30 to choose from. But then you have or. So or you could choose anyone from the G group. But you can see that as I'm coloring in G, I'm actually repeating this group in the center. True? But really all they're asking is how many people in total? Well, I've just colored all my options. There's 11 people here, 8 people here, and 10 people there. So in total, 11 plus 8 plus 10 gives me the union. Gives me a probability of G union A. Get that? And if you look at the two-way table, you can also see, well, where's 11, 8, and 10? Well, 11, 8, and 10. If you actually add those three there, except for the one that isn't part of A and not part of G as well, if you add all those three, they will also give you the union as well. So that's another way to figure it out. So the answer now, I'm just going to rub all this out here so it doesn't get too confusing. There we go. You can see that. I'm just going to rub the colors out. There we go. Answering the question, what's the probability of picking someone that's going to attend or use the gym equipment? Well, that must equal to 11 plus 8 plus 10 over out of 30. So that gives you a total of what? 19, 29 out of 30. That's your chances of success. Okay, so hopefully you see how it works today. It's literally just getting yourself used to using two-way tables and the Venn diagram to visualize the problem and then solve.